Welcome. We are continuing our discussion on calculus where we are integrating by the rule. So if dy dx is equal to ax power n, then y is equal to ax power n plus 1. Everything over a plus 1 plus c for all n except n is equal to negative 1. So the value of n should not be negative 1, because if it is negative 1, we could have a 0 as the denominator. And you know, in mathematics, division by 0 is illegal. So we have the examples. Integrate the expressions a 5x, b 5x squared minus 4x plus 5. So we say solutions. We have our dy dx is equal to 5x. Now we have to get back our function y, from which this dy dx was gotten from. So we shall say y is equal to, so when we are given our dy dx as this, so this is our dy dx, 5x, we are supposed to integrate by the rule that we have. So we need to identify our n, which is the power of a particular term, and the coefficient of this variable whose power is n. So you can see the summary of the rule is you add a 1 to the power, then you divide by the new power, then you add the arbitrary constant c. So c is called the arbitrary constant. C is called the arbitrary constant. So the rule under discussion is this. This is the rule that we are supposed to use on our gradient formula, our gradient function, our derivative. This is the rule that we are supposed to redeem our f of x or our y back. So, okay, so let's get our y back in our case. So the gradient formula that we have is 5x. So you can see when a variable is alone, then it means it has a power 1. We need this power 1 for the sake of calculations. Normally, we do not write it because the variable is already 1. But for the sake of showing our working, we need to reintroduce it. So we have, according to the rule, we are supposed to add the 1 to the power, then we divide by the new power. So our y is equal to 5x power 1, this power 1 which is already there. According to the rule, we add a 1, we divide everything by the new power, then we say plus c. So that our function will be y is equal to 5x power 2, everything over 2, plus c. C is called the arbitrary constant. So basically, our function y should look like this. Our function y should look like this. Okay, so this is it about 1A. Let's look at 1B. Okay, so 1B, our dy dx is 5x squared minus 4x plus 1 plus 5. Sorry. According to our rule is defined on one term, but here we have three terms. We have this one, and the other one. So we have three terms. So we need to apply the rule on each one of the terms that we have in the expression, in the gradient formula. So we shall say y is equal to, so we apply our rule here. So we say 5x power 2. The rule says we add the 1 to the power, we divide by the new power. Minus, we have taken this side, 4x power 1. As you can see, x as a power 1, even if it is not written there, because it is already alone. But for the sake of showing our working, we need to reintroduce it. So 4x power 1. So we add the 1 to the power, we divide by the new power. Plus, again, we apply the rule on 5. So we have 5. Now, 5 as a variable x power 0. We need to reintroduce our x power 0 for the sake of showing our work. Any number which has a power 0 is 1. And 1 multiplied by 5 is 5. That's why it was just removed like that. But as we do our calculation, we need to reintroduce it. Okay? So we add the 1 to the power, we divide by the new power. Then we say plus c, So our y is equal to 5x power 2 over 2 minus 4x power 2 over 2 plus 5x power 1 over 1 plus c. Yes, so this is what we have. So finally, our y is equal to, 5x power 2 over 2 minus 2x power 2 plus 5x plus c. So this is our y. So basically, this is how we use the rule to integrate polynomials like these ones. The rule is defined on one term, but in a case where we have more than one term, we need to apply the rule on each and every one of the term. Then we say plus c. Why we are saying plus c is because the derivative of a constant is 0. So that's why we expect whenever we integrate, we expect that there was a constant, but we don't know the value of the constant. That one will be discussed in our next lesson. Thank you very much for your attention.